exploring eutrophication, an aquatic systems ecology perspective.
Welcome to the Universal Principles podcast. Today, we're diving deep into eutrophication. Simply put, it's when bodies of water get too many nutrients. But what does this mean for aquatic ecosystems?
Thanks for having me. From an aquatic systems ecology perspective, eutrophication is a critical issue. It's essentially overenrichment, leading to a system collapse. Think of it like this: too much of a good thing can be devastating. The higher concept is that unchecked abundance can disrupt natural balances, causing more harm than good.
Could you walk us through a concrete example of eutrophication in action?
Certainly, a classic example is agricultural runoff. Farmers use fertilizers containing nitrogen and phosphorus. When it rains, these nutrients wash into nearby lakes and rivers. This sudden influx of nutrients fuels massive algal blooms.
So what's the big deal with algal blooms? They sound almost pretty.
Unfortunately, they're far from pretty. These blooms block sunlight, preventing aquatic plants from photosynthesizing. When the algae die, their decomposition consumes huge amounts of oxygen, creating dead zones where fish and other aquatic life can't survive. Another example is sewage discharge. Untreated or poorly treated sewage releases similar nutrients, exacerbating the problem.
Yikes, that sounds dire. Are there any other specific cases that highlight the severity of this phenomenon?
Absolutely, the Baltic Sea is a prime example. Decades of industrial and agricultural pollution have led to widespread eutrophication, resulting in vast dead zones and significant damage to the ecosystem. This impacts fisheries, tourism, and the overall health of the sea. It's a huge, complex problem requiring international cooperation to address.
It seems like the effects are devastating. Are there similar principles that cause collapse in other domains?
Indeed, consider the population bottleneck effect in genetics. A drastic reduction in population size can lead to a loss of genetic diversity, making the remaining population more vulnerable to diseases and environmental changes, potentially leading to collapse. It mirrors eutrophication's overenrichment, leading to ecosystem collapse, just in a different context.
So what practical steps can individuals or organizations take to combat eutrophication?
Great question. First, support sustainable agriculture practices that minimize fertilizer runoff. Second, advocate for improved wastewater treatment facilities. And third, educate yourself and others about the importance of reducing nutrient pollution.
Those are some great tips to get started with understanding eutrophication. Thanks for shedding light on this critical issue.
My pleasure. It's a complex problem, but understanding the underlying principles is the first step towards finding solutions.
And that's all the time we have for today on Universal Principles. Join us next time as we explore another fascinating concept.